Okay, this is a virtual lab that I've used several times in my classroom, and I really like it. What it does is it teaches natural selection using a fictitious population of these weird little organisms. It gives you a good introduction starting forward. I really love this page here where it talks about the things necessary for evolution to happen. It explains the simulation. In this, you have the little blue grabber guys, and you have their food source, and their food source drops down to them, and they grab it and eat, or they fail to and die. So it's kind of neat. And here's the actual simulation. And so as you go through it, we can run just one cycle. And there you see the little food source wiggles back and forth. Down on the bottom, it's how often it's been since the grabbers ate. So that one ate, and it reproduced. And one of the ones that hadn't eaten in a long time died off. And we see the same thing again, but this time the little sound indicated there was a mutation. And so what happened is the grabber that was replaced, or that it was replaced with, now can only reach one square. That's what the little yellow thing indicates, is how far up they're able to reach. And so we can continue this process and continue the replacements. We'll go a few more cycles here. Another mutation, and it shrank, and it no longer can go as high. If we keep going forward, though, we'll notice that mutations are set at a constant rate, but they're equally as likely to go up in terms of what they can reach as they are to go down. So let's see if we can get through 10 cycles here and see if we get one that mutates the other direction. We're lucky. There we go. So now in 10 cycles, we've seen 2 that have mutated such that they can't reach as high, and 1 that's mutated that it can reach higher. I think that's good because it shows that the mutations are random. It doesn't mean that they mutate in the direction that will give them a benefit. But as you can tell, reaching higher is a benefit here. And so if we run it more cycles, so we can crank up a few cycles at a time, we start to see the population shifting. And so they have a graph up here on the top left that you can look at. And if we keep marching through, we'll see more and more of our grabbers can reach higher and higher. And we can run it one cycle at a time, or we can continue going. But as we keep marching through, we see more and more and more of the grabbers start evolving so that they actually grow higher, even though the mutation rates are equal in both directions. So I think this is great. There's some settings that you can change, which I think is also neat. You can change the selection strength. So let's say if we drop that down to 0, in this situation when we run it, the food sources drop straight down. So it doesn't matter which way you can reach, and you can run that up to 50 cycles. And we see that we get an even distribution of grabber height because there is no selective advantage. And I think that's kind of neat. So I think this is good. And I've used it with my students. I have a little worksheet that I accompany with it, and they get to run it a certain number of cycles. What I will say in my experience is it's hard to get the kids to really focus in on what's happening and finding the graphs and talk about it over time. They get really excited about the sounds and the clicking, and sometimes get a little distracted. But I think that the content is good, and it does a really solid job of explaining a relatively complex concept. And I start out my evolution unit with running this in another simulation.